Okay, put on your seatbelts. We've got 15,000 years of geologic history to cover in 20 minutes, so get ready. This is going to be exciting. So I live in the state of Washington. It's an incredibly topographically diverse state. As a cartographer, I'm in heaven, so here's my state. We make maps at the survey for a lot of reasons, but one of the reasons is to tell the geologic history of our state. And a great way to do that is to talk about the glaciers of the past 15,000 years, because they have shaped literally almost every part of the state in some way, shape, or form. They've shaped the state through direct contact with glaciers that have ground out the landscape. They've shaped the landscape through incredibly huge ice age floods that have scoured the landscape. And then last but not least, they've also left a lot of fertile soil with the glacial silt that's been blown around the state, especially in eastern Washington, called loess. I'm going to probably talk mostly about the first two here today. So I managed to get my hands on a 15,000-year-old photo. It's pretty exciting. But this is about what most of the top third of Washington looked like 15,000 years ago. It's very heavily glaciated. The Cordilleran ice sheet came down from Canada and scoured out a lot of Washington state. A large part of that scouring is where everybody, not everybody, but the majority of the population lives in Washington, which is the Puget Lowland region. You can see this map from the 1960s from Alan Carey, the U.S. Army Corps of Engineers. So it's actually quite a beautiful map, hand-drafted, and he drew the Puget ice slope as it would appear over top of modern-day cities in Washington. So you can see Seattle and Tacoma and Olympia there. He also made some maps showing some of the glacial lakes that were formed by the ice. They basically dammed the water in a lot of these rivers, and most of modern-day Puget Sound used to be part of a lot of these lakes over time. So my predecessor at the survey actually took this map, did an additional drawing, basically by tracing this map, a nice little pointillist drawing, for a project at a local park in Olympia. And this was overlaid with geology. You could slide panels back and forth, and it worked really well. When I came on, I actually took it one step further, kind of refined the extent, because we've learned more about where the ice actually was since then, and kind of put it in this old-timey sort of map. We have additional maps, and I just want to say I'm going back and showing some of the older maps going back probably 100, 130 years. Some of these maps are. Just to show some of the great geologic research that we use to bring these maps into the modern day. So this was actually from Robert Thorson's thesis at the University of Washington in the 1970s, and he did some great research on glacial rebound and had some fantastic little figure maps that we use a lot at the survey. So this map is actually showing how ice receded as it melted away later in the Ice Age. So using that data, I actually took that original drawing and made 12 different iterations of it to show the ice as it was receding back. And then using that data, we could show different iterations of where the lakes were, where the ice was, and we produced a little interactive map for our website showing the glacier as it receded over time. At this point, I'd just like to recognize the fact that the only reason we know any of this stuff is because of mapping geologists in Washington who've done a great job over the past 100 or 150 years. This is a simplified map by Thorson, a simplified geology map showing where some of the glacial deposits were left behind. And here's one of our maps at the survey from a couple years ago, which actually refined the edge of that ice lobe a little bit. This is an additional map from Robert Thorson. This is showing actual ice depths, so those ISO lines are showing the depths in the region. So we took that and again added some modern day cities to it. You can see that Seattle is underneath about 3,500 feet of ice. So pretty crazy to think about these days. We've done a number of maps and graphics for projects on the Ice Age floods in Washington, and if you don't know about the Ice Age floods or the Missoula floods, I highly encourage you to check it out because it's a fascinating subject. Basically, there was an ice dam in where about Idaho is today, in northern Idaho, that blocked a major river valley. A huge lake backed up into Montana, And over time, as that ice started to melt, it released all the water at one time. So they estimate that this happened about 40 separate times. And the amount of water was huge, and it scoured out landscapes like this. This is Palouse Canyon, part of the channeled scablands in eastern Washington. So that little tiny river did not carve that canyon. So. The person who actually is credited with figuring this out was J. Harlan Bretz. He was a geologist that worked a lot in Washington in the early part of the 20th century. No one believed him. They didn't believe him until 3 or 4 decades later that this actually happened when it became accepted geologic theory. So this is one of his later maps of the channeled scablands that we've used as a reference. This map isn't very old. This is from the 90s. The U.S. Forest Service put together a pretty comprehensive map of the ice and the scoured areas in eastern Washington, as well as Montana and Oregon. It's hard to see some of the features on this map, though. So about 10 years ago, the Eastern Washington University made a refined version of it that show the scoured areas of the scablands a little bit better. We wanted to create a somewhat simplified, colorized version of this map that was simplified for a project, an Earth Science Week a couple years ago. So we created this map based on those earlier maps. And we kind of simplified it by combining the lakes with the Ice Age waters affected areas. So those are everything that's in blue. On a later project, we actually took this a step further and broke that map apart into 7 separate maps. And we included this in our story map on the Ice Age floods. But basically, this is a user-controlled animation where they can go through and see where the floods went. And this was accompanied by interpretive text that told a little bit about those areas that the floods affected, went all the way to the ocean. So it's pretty crazy the amount of area. It went all the way down to Eugene, Oregon. So pretty impressive story. Here's a smaller cropped-in version of Bretz's map in that eastern Washington. The channeled scablands in Washington are so impressive. You can definitely see them from outer space. You can see the brown areas there, areas that were scoured, compared to the less covered areas that are now farmland. So we took that map and made it into kind of this stark version of the channels just by using elevation data and kind of tweaking that a little bit so you can see the channels really vividly. Okay, Mount Rainier. So Mount Rainier, it's the most heavily glaciated mountain in the lower 48 states in the US. And fortunately for us, it's also one of the most mapped mountains in the lower 48. It's great to look back at tons of, mainly the USGS are the ones that map this mountain a lot. This is a map from 1896 that's pretty incredibly accurate considering the time period. And it's fun to go back and compare that to modern day LiDAR. Here's a comparison between a map from 1924 and the LiDAR from 2008 showing aerial change of the glaciers. Bird's eye maps, love them. There's a lot from the late 1800s in a lot of part of the United States and Canada. There's some really great ones in the Pacific Northwest as well. This particular one is showing the view over Tacoma, which next year, hopefully you all be here, with Mount Rainier in the background. Now the interesting thing to me in this particular map is that mid-ground area is the Puyallup River that empties out into the bay near Tacoma. They didn't know this at the time, but most of that land there is built on lahar deposits, which are volcanic debris flows from Mount Rainier. So take that into the modern day. This is a little further up the Puyallup River near Ording, Washington, and the entire valley of Ording is on a lahar deposit. So this is a lahar hazard zone. So basically, if Mount Rainier ever heats up on that western side of the mountain and rapidly melts a glacier, that's not where you want to live, to put it mildly. And if you look closely, you can see all the little housing developments in that valley. So somewhat terrifying. I'm glad I don't live there. So in Washington, we have one of the deepest lakes in the United States, and the reason it is so deep is because it was carved out by 2 separate glacial lobes that came together. Lake Chelan in eastern Washington. I think it's the 3rd deepest lake in the US, I'm pretty sure. So we have this report from the 1980s by the Washington Department of Ecology, and I have to say, some of these maps aren't that great, but the research behind them is amazing and really valuable to us as cartographers. So we took this data, we read the report and kind of looked it over and wanted to spruce this depth profile graph up a little bit. So, we added some color, added some more context by putting some towns. The really fun thing about this, though, is adding the space needles on the side for reference for Washingtonians. This is an extremely deep lake, just to give you an idea. It's 2.5 space needles deep. So I think the bottom, almost 400 feet, is actually below sea level. So very deeply carved glacial lake. So we added this onto a perspective view map of the lake's watershed to add a little extra context to it. This is one of my favorite parts of Washington. It's a weird place. Have you guys heard of Mima Mounds before? There's kind of these unexplained mounds actually around the world. There's some in Africa, there's some in other parts of North America. But this is actually Mima Prairie. This is what all those mounds are named after. And the Mima Mounds in the South Puget Sound region are unexplained. No one's really satisfactorily come up with a reason why they're there, but they all seem to exist on glacial outwash prairies. And this is some UAV footage from a few weeks ago of Mima Prairie. But before J. Harlan Bretz discovered the Channel Scablands, he actually worked in southern Puget Sound in the early 1900s. So this is a little hand-drawn map that he did of the Mima Mounds. It kind of reminds me of, maybe an Aboriginal drawing or painting. Very simple, but very effective at the same time. A little bit closer look. So we still haven't figured out why they're there, how they're there. Some theories are they credibly range from earthquakes to giant gophers to aliens. Maybe that last one's not so credible, I don't know. But we have LiDAR data of this area now, so we can create these kind of crazy looking false color images. They almost look like goose skin or something across the landscape. So maybe someday this will help to figure out why they're there. And here's a LiDAR point cloud image of that same area. And most of these are about 30 feet wide and 6 to 8 feet tall, to give you a little extra context. Some additional places in the Puget Lowland. Everything you see here was covered in ice not very long ago in a geologic sense. Another map from Thorson. So this is actually showing the direction that the ice moved across the landscape. It's a very simple map again, but the main reason that we know of the direction of this ice is because of glacial drumlins. And these are fluted ridges that, when that glacier scoured across the landscape, they left these features behind. And the main reason that we can really make these pop out and see them is because of LiDAR data. So if you look at a photo of the area, you can see them if you're looking closely and know what to look for, but they're a lot more difficult to discern. So one of the amazing things about J. Harlan Bretz is he figured this stuff out when there was trees covering everything, and he didn't have the benefit of LiDAR, of course. Robert Thorson's thesis was actually about glacial rebound, so the effect when the glaciers recede, the land will actually lift up because it no longer has that heavy weight of the ice on top of it. And one of the great things about Washington LiDAR is you can actually see this, especially in the San Juan Islands. There's areas where you can see former shorelines, so you can see those contour, somewhat like contour lines. Those are where the ocean was at different times. So that's a result of the land rebounding and sea level moving up and down. Aspect-aware contours. John Nelson, I was like, these are aspect-aware contours. Just reminded me of that book cover. So there's all these really great examples on the landscape, almost like fingerprints on the landscape from ice in the past, from the past 15,000 years that I thought, it would be really great to just make a more comprehensive picture of the Puget Lowlands and take some of these examples and kind of explain them a little bit better. So luckily for us, we have LiDAR of almost the entire Puget Lowlands. So we took some of that data, crunched it together, made some enhancements. I love Photoshop, so spent some time in Photoshop and then made a map out of it. Here's a little bit closer view. So we took 6 examples and kind of gave them a little better explanation. And this map is in the Atlas of Design this year, so pretty excited about that. Additionally, we added some interactive graphics to our website that also explain a few more of the landforms that weren't on that map. So you can go to our website and see some more examples of that. One more project we have upcoming in the next year that we're really, really excited about is we're calling it the Washington 100 project. And this is going to include a lot of glacial affected sites, but we're basically picking 100 sites in the state of Washington where you can see really awesome geology, and they're all on public land, so everybody can go to them and check them out. So we're making all sorts of maps, graphics, illustrations of a lot of these places. So this is a draft map of Mount Olympus that we're going to have included in that project. All right, we got through